Uncertainty problem. The volume V of liquid flowing in time t through a pipe of radius r is given by the equation showing here, where P is the pressure difference between the ends of the pipe of length L, and C depends on the frictional effects of the liquid. An experiment is performed to determine C. The measurements made are shown in this table. Calculate the values of C, and here is in Newton second per meter square. Calculate the uncertainty in C, and finally show the uncertainty with appropriate number of significant figures. First, we arrange this equation for C. I just did cross multiplication here and here, and this is what I got. HClV is equal pi p r to the 4th power t. So I kept C on the first part of this equation, and I moved 8 L and V to the denominator on the other side. Now, let me look what I have from this table. P, yes I do, is 2.5. Remember, this here means that is to the 10 to the 3rd power Newton meter per square meter. So don't worry too much about the units here. On these, yes, because you want your answer in meter. Don't worry about this one, you already have in meter. And this one here, you already have in meter, cubic meter per second. Which is the unit is correct, the unit is fine. This one, we need to millimeter is 10 to the minus 3 meter, and the rest is correct. So you have the value of P, which is here. You have the value of R, which is here. We have the value of T and V. This one here we don't have directly. We have a ratio right here, V over T. However, this is inverted. So one easy way to solve this problem here is when you do your substitution, instead of write on the numerator the value, you are going to write on the denominator because it's flipped. Please don't get confused. So P here, 2.5 times 10 to the 3rd. R is right here, 0.75. Now remember that we need to convert to just to meter. So times 10 to the minus 3. All these to the 4th power over 8 times L, 0.25. Now again, it's T over V, but I have here V over T. So I just write on the denominator the value because is inverted. Let's plug all these in the calculator on. So let me start with, actually let me start with this one that is to the 4th power. So 0.75 EE negative 3 equal to the 4th power. I'm gonna use this key, right? This key, 4th, boom, that's the result, times 2.5 EE to the 3rd power equal, divided by 8 equal, divided by 0.25 equal, divided by 1.2 EE negative 6 equal, and the result I need to multiply by pi equal. Now I'm going to write this result using kind scientific notation, which is I may have to move my decimal right here to this location. So 1, 2, 3. So this is 1 point, let me round this to 4. 0.4, okay, 0.4 times 10 to the minus 3, and this is the unit. About the unit, my recommendation is just to check if you have everything in place. In this case, meter and kilograms, those are things that we need to pay attention. So because this was in millimeter, so we need to convert to meter, so we are covered with all this. So you can check the units, but as long as you do your conversion right here on the table before actually you do your computation, should be fine. Now is asking to calculate the uncertainty in C. For this, you need to look all the variables that are involved in this formula. So we have a lot of variables involved here. So the uncertainty for C is the uncertainty for P, uncertainty for R, uncertainty for length, and uncertainty of this ratio, which is flipped, which is okay. Now one correction. So since the R here is to the 4th power, so we need to make the correction here and add 4 times this. So to find all these uncertainties, fractional uncertainties, what we do is we look the information from this table. For example, for P is the uncertainty, which is 0.05 divided by the value. For R is the uncertainty, which is 0.01 divided by the value, 0.75. For L is 0.001 divided by 0.25. And for V over T or T over V will be the same approach, because on both cases, even though if I didn't write this way, I did V over T instead, it still go the uncertainty over the value, so it will not change anything. So 0.01 divided by 1.2. Now I'm going to divide all this, add, and place the result right here. So 0.05 divided by 2.5 plus 4 times 0.01 divided by 0.75 plus 0.001 divided by 0.25 plus 0.01 divided by 1.2 equal. So here, this is what I got, 0.0856, so I am just writing 0.0856. Great, so this is my value, no units. So I need to present my uncertainty with unit. So to incorporate the unit, I need to multiply by the value of C that I calculated previously. Okay, so now that I have the uncertainty for C with this value, I need to add this unit by multiplying the uncertainty by the value of C, which is this one, and this is what I got. Now I want to present my uncertainty with the same 10 to the minus 3 power. So I have to move my decimals here in order to get the same format. So I'm going to move my decimals to the right, so it'll be 1, 2, 3, so it'll be 0.089. So 0.089 times 10 to the minus 3. 1, 2, 3. 0.089. So to finalize this question, we are going to do something here. I'm going to present both results, the value and the uncertainty. Here, actually, I closed too much. The times 10 to the minus 3. So both with the units, same units here, because I introduced the units from this when I multiply. So this should be a Newton second like this. So both they have the same units. So my focus now is this value, and actually I should write here 0.089 times 10 to the minus 3. So this right here. Okay, so now I'm going to present this is 1.04, and I have 3 significant figures here, so I should have 3 significant figures here as well. So I will need to round this to 9, so that will be 0.09. Now I have 3 significant figures here instead of 4, 3 significant figures, and that's the final answer. So this is a final results of my work. So rearrange the formula, find the fractional uncertainty for each variables that make this formula, and add all of them. And then you multiply by the value of C to add the unit. And then you rearrange everything to present in the way they are expected on your structure question, which means the same number of significant figures. And if you have the 10 to the power, so you need to match with both values, with the value and its uncertainty.